So while we're waiting on people to come in, I do want to talk about the assignment from last week. Hopefully everyone's got that done. There's a few people that are still missing it on Friday when I checked, but most people had that done. It is worth 10 points. So that'll mean either you got 100% this week or you have a 0 this week, depending on whether you did or not. Because I didn't grade it for accuracy. It's like, do you have all the answer 100% correct? I just said, did you do it? Okay, 10 points. You did it. That's what I was looking for. It's not usually how I grade in math, right? Usually it's like, okay, well, that's wrong, but you got some points, you missed some points. But this was all or nothing. Either you did it, got 10 points, or you didn't turn it in at all, got 0 points. So I'll be updating the grade book here later on in the day. So if you don't have it done yet, go put your answer in there. Think about that. But we're still missing 5 folks. Hopefully they'll be rolling in the door rather quickly. But I want to put this up on the screen because I want us to talk about this assignment that I had last week, because just wanted to get your thoughts mathematically. All right, here it is up on the screen. So I gave you this equation, and I said A, B, and C were all integers. Right? I said A, B, and C were all integers. So this was your assignment last week. And I said, so A, B plus C equals B plus AC. So both sides have B plus C. So it's B plus C equals B plus C, except we're taking the A on one side and multiply times the B. And on the other side, we're going to multiply A times the C. But it's an equation, and it says that those are equal to each other. So I said, for this to be true, for it really to equal each other, what limitations are there? What can A, B, and C be? For example, can they all just be any number? Or is there only one number that A can be? Or is there only one number that B or C can be? Basically, what's possible? So that was our assignment last week. And like I say, on Friday, there was only 3 people who hadn't done it. Hopefully you got it done over the weekend. I haven't checked yet today. I'll need to go in and get the grade book updated. So I haven't checked yet today, but hopefully you've got some thoughts in there. But I want to get your thoughts now. A, B. I'll write this down on my paper. We're going to switch over to actually work with it just a little bit. All right, I'm going to put this up on the screen. AB plus C equals B plus AC. Now, there were some people I saw, because I was just glancing at all the answers. Some people said, oh, they can be any number. So it's like, okay, so if they can be any number, that means A could be 3, B could be 4, and C could be 5, right? Because that's just any number, 3, 4, and 5. So what would it be? This would be 3 times 4 plus 5 equals B is 4, 3 and 5, plus 3 times 5. Okay, that's just any number. 3 times 4 is 12, plus 5. 4 plus 3 times 5 is 15. So this is 17 equals 19. Okay. Got you. All right, Madison, you're good. So obviously they can't be any number because this is not true. 17 does not equal 19. So any number is out. So give me some thoughts. What some of you may remember what you answered this, or maybe you've got new thoughts this morning looking at this. What do you think? Is there any solution for this equation? And if so, what does A, B, and C, what are they limited to? What do they have to be? Because I got some really good answers last week looking at it. A lot of really good answers.
I think it was no solution.
No solution at all? There's no numbers that would make that true at all.
Right. Because
that's right. Because this didn't work, there's nothing that would work.
Right.
Okay. Anyone else got a thought? Did anyone come up with any numbers that worked? No, people are afraid to speak up. All right, Jonathan. People are afraid to speak up. Come on, I saw a lot of thoughts on there. We're throwing out any thoughts we have here, and then we'll investigate. Sometimes if we don't know the answer, we start down a path and see if we can figure it out. That's what we're doing.
A can be anything, but B and C can be anything. They just have to be the same.
Oh, that's an interesting thought. So A is all real numbers. We'll make that R. All real numbers. As long as B equals C. All reals. All real numbers. So let's just try one then. So let's say A is 6. And we will say B equals C. So they will both equal, let's just say 4. So let's see if that works. So 6 times 4. Oh, that pencil lead is about to break off. Let me grab another pencil. I got to get my pencil sharpener back out. I still got it packed up from the summertime. Yeah, that would work. 6 times 4 plus, since C is the same number, 4 equals 4 plus A times C, 6 times 4. Oh, that looks right. 24 plus 4 equals 4 plus 24. Hey, look at there. 28 equals 28. That one worked. And you said as long as B equals C, so we can leave those in. Let's just change this to like 10. So A equals 10. So then it would be 10 times 4 plus 4 equals 4 plus 10 times 4. 40 plus 4 equals 4 plus 4. Hey, that looks like it's going to work every time. Okay, so that is one possible solution right there. A can be anything. Let's just say A can be any number. Let's say infinity. As long as B and C are the same number. Oh, I love it. See, that's good thinking there. There's a way to make that work. So this will be true every time because really we're just adding B plus C both times. We're just moving the A. So as long as B and C are the same number, A can be whatever. That's great. Did anyone else find anything different or see anything different you thought? Because I will tell you, there are other solutions other than B and C. What if B and C are not the same? Is there any solution? B equals 2, C equals 4. Is there any solution that would work for A? A times 2 plus 4 would equal 2 plus A times 4. Is there anything that would make that work?
Can you do like 1 for 8?
Oh, I was hoping someone would say that. Yeah. 1 times 2 plus 4 would equal 2 plus 1 times 4. So both sides are 6. So if B equals C, A can be any number. If A equals 1, then B and C can be any number. Oh, see what we discovered? A equals 1, B and C, any number. Because all we're doing is adding B and C together on both sides and multiplying by 1. Any number. Great. Love it. Good thinking. All right. I'm sure there's more answers we can come across, but we've already got an infinite number of answers because A can be an infinite number right here. So we could write an infinite number of equations that would work as long as B and C are the same. And B and C wouldn't have to be 4. They could be 3. They could be 10. They could be 21. Doesn't matter as long as they're the same. All right. That's some good stuff. That's some good stuff. That's what I want us to do. When we get an equation like that, when we're solving things and talking about things this year, think about how it works. I mean, this works because you're just adding B and C together on both sides, but the only change is we're moving the A from this side to this side, right? We're doing different numbers. So when we think about that, oh, well, if B and C were the same, doesn't matter what A is. Or if A is 1, doesn't matter what B and C. See, getting deeper into just what's a solution. This. All right. Good stuff. I appreciate your contributions on that. All right, I'm going to close that down. I had a lot of people. A lot of people thought that A, B, and C could be any number. We had people think they couldn't be any number because it wouldn't work. Some people figured out that B and C have to be the same. Some people, I had someone say A can be any integer except 1. Okay, now that it's like, okay, I'd like to get more into the thinking of that, but I don't know. But I had a whole bunch of different answers on that, and a lot of people figured out B and C being the same, or A being 1, or even a few other things that could kind of play into there. But I like it. There was a lot of good thinking on that. So, all right, we're going to go to Buzz. We're going to look at our lessons this week, see what we got to do. We got a lot of stuff we're going to look at this week. And what is that right? It says it's a number 2 pencil, but I didn't like how that was writing. We'll get my pencil sharpener out here before next class. We're going to go, Buzz, and look at this and see what we have this week, get our assignments so we know. Oh, while I'm thinking about it, before I forget, this is a B day Friday, so Wednesday is the only other day for this class. Wednesday, our principal, Miss Scott, still wants all the virtual classes to meet on Wednesday because she likes us to meet for the first 2 weeks every day. Well, we had boot camp on Wednesday, the first week of school, so we didn't start meeting until Thursday. So for her, 2 weeks is Thursday, Friday, all the way to the next week, and then to Wednesday of the second week. So this is Wednesday is a mandatory class day this week in all your virtual classes. Now, in this class, it's going to work a little different because I'm not here Wednesday. I have to be in Little Rock. I got to have a checkup on the ear surgery I had this summer. So I will be out on Wednesday. So you still have to be in attendance on Wednesday when no teacher's here. So how's that going to work? This is how it's going to work. On Wednesday morning, I will post a Google Form assignment in Google Classroom. And when I say assignment, it's not going to have any math on it. It's merely an attendance assignment. You go in on Wednesday and said, "Oh, yep, I'll fill out the form. Look, I was here. Here's my name. Here's, and I'll ask like 2 or 3 questions, like, have you got your assignments turned in, or whatever. It won't be any algebra to do. It'll be just 3 or 4 questions. Then you just go fill it out and submit it, and boom, you were present in class. That's all it's going to take to be present in class. So do you have to do that at 8:55? No, because I'm not going to be back till late in the day. And I'll go say, all right, who did it? Who did not do it? Because that's who's absent in class. See, that's the main thing. Like, who didn't turn in the form? You're absent in class if you didn't turn in the form. So that's how attendance is going to work on Wednesday. It will be posted Wednesday morning in Google Classroom. I'm not going to be here. So all you have to do to be counted present Wednesday is to fill out the assignment that pops up in Google Classroom on Wednesday morning. All right. Questions on that? I don't want anyone to be counted absent because you didn't understand. All right. So as long as you fill out the Google form and submit it, you are present on Wednesday. So easy as that, guys. Easy as that. So yeah, if you got any questions on that, please ask or email me if you think of it later, because I want you to be counted as present and not counted absent on Wednesday. So just get it done during the school day on Wednesday, and you're fine. All right. I'm going to pull up Buzz. We're going to look at our lessons. We got to get moving along here. Starting out, I want to show you if your screen looks like this, you're going to have problems. If your screen looks like this, you're going to have problems because there's going to be some equations, some fractions, and different things you see throughout the semester. You're like, I can't read that number, Mr. Brock. I don't know what that says. I don't know how to do this problem because I can't read it. Well, it has nothing to do with your ability to read. It has the ability, it has something to do with how Buzz is showing it. So if your screen looks like mine, and what I mean is a gray background with white letters, go up here, click on your name, and you see this little menu pops open. Choose theme is the second thing. Choose theme. If you go there, there's a little drop down menu right here. You can change it to a light color scheme. When I change it to a light color scheme, it's going to make it like this on the right. And you can still choose what color you like for accents. Like I've got the red selected right now. When you hit save, it will totally change Buzz to where now you have a white background with black letters. And now those fractions and other equations that you could not read before, you can read them now. So if your Buzz has a gray background, go up there and change the theme. It's right there at your name. Choose theme, change it to a light background rather than a dark background. And that will fix that for you. So I just want to make sure everyone from the start, because usually I forget about that at the beginning of the year. And then we're like a month in and I got a student that says, I can't read an equation. And then I figure it out and go, oh yeah, I forgot to tell them to change it to a light background, and then pick whatever colors you want, for your other thing. But all right, I'm going to go to the grade screen to see what our assignment is this week. I can click on this right here, or I can go up to the menu. Either way, grade screen. If we look at this, we have 2 assignments this week. We're going to do the review, and we're going to revisit what a function is. So this first unit, we're going to jump in there, get some things done. 2 things this week. Next week it shows 3, but it's not 3 lessons. Because one of them is just a quiz over this week. So that's nothing for us to review in class. We'll do 2 different lessons next week as well. So 1.01, 1.02. Algebra 1 review, revisiting functions. That's what we're going to go through this morning. So let's go take a look at that. Algebra 1 review lesson. All right, we're going to start off talking about order of operations. So we're going way back. We're going back to Algebra 1, probably even going back to junior high math right here. Order of operations. So it basically talks about the reason we're doing this is so you have a block foundation. So it says, suppose you got this pile of blocks that have been carefully stacked up to build this little shape right here. And imagine grabbing one of them off the bottom and pulling that out from underneath the stack. Whole thing falls apart to where eventually you don't have any kind of shape anymore. You just got a bunch of blocks laying on the ground. Basically, think of that as Algebra 1. If you didn't know all the stuff from Algebra 1, your whole stack's going to fall apart. So on top of that's Algebra 2, and it won't stay there. Algebra 3 certainly won't stack up if we lose the foundation from Algebra 1. So we're going to have a solid foundation. So we're going to learn how can the order operations be used to simplify expressions? How does that help solve 1-step and 2-step equations? What important procedures are required to solve an equation that has a variable on both sides of the equal sign? And when is it necessary to use the distributive property? So let's look at page 2. Order of operations. If you remember the order of operations, some teachers have little cute sayings you can do to remember that. Please excuse my dear Aunt Sally. I've heard a whole bunch of different ones. Man, I can't even think of my favorite one right now. My brain's not clicking this morning, but there's a lot of good ones out there.
I like to use GEMDOS.
GEMDOS?
GEMDOS, grouping symbols, exponents, because grouping symbols, we may have brackets, we may have braces. You never know what it is. So I like grouping symbols.
Okay. All right. So there's a different explanation way to remember that. But basically, parentheses or whatever type of symbol it's using there is the first thing you have to do. You have to simplify the parentheses. And then any exponents that are in your equation. Now, of course, if there are no parentheses, no exponents, you just skip those. So the next thing is multiplication and division. And those are side by side because you do them from left to right, whichever comes first. If the division is on the left side first, you do that first. If it's on the right side, you do it last after the multiplication. So multiplication and division are side by side, and you just go from left to right. And then addition and subtraction, the same thing. You just take those in order from left to right, whichever you come into first in the equation. So for example, if we look at this, we've got a minus, a plus, a divided, and a multiply. There's no parentheses, there's no exponents. So we skip those. So the first thing we need is any multiplication and division from left to right. Well, the first thing we see, and it's going to write it again, the first thing we see between division and multiplication is the division is first. These are all add and subtract, so we skip those because we're not ready for that yet. So the first thing we want to do is this divided. So that simplifies to a 5, right? 10 divided by 2 is 5. If we had done the multiplication first, we'd have 10 divided by 10, and that'd be entirely different. Because the next step would be, now we do the multiplication, so that turns into a 25. If we'd done the multiplication first, 10 divided by 10, this would have been a 1 instead of a 25, because 10 divided by 10 is 1. So we have to do those in the right order, or we get the wrong answer. The wrong answer. So continuing on, now that we've finished all the division and multiplication, now we do the addition and subtraction. The first thing that we see is the subtractions first, going from left to right. So the first thing is change 16 minus 4 to a 12. Then we've got 12 plus 3, which is 15. And then finally, we equal with 40. So all of this mess right there is just 40 when we simplify it using the order operations. So hopefully this is just a review and you're like, yep, I've got all that. I remember it. But in case you didn't remember it, it's here in our lesson as a nice refresher. So there's more examples there. Example number 1, 3 minus 5 times 4 squared. There's no parentheses, but we have to do the exponent first. 4 squared is the same as 4 times 4. So now it changes to 3 minus 5 times 16. Multiplication will be next. So it's 3 minus 80. And then 3 minus 80 is going to turn into negative 77. So that's what this simplifies to. Negative 77. Remember, if you have, oh yeah, this is a good point. I probably should put this on paper because definitely want this part of our notes. There is a difference between these two expressions. Those are not the same. Negative to the fourth, or negative 2 to the fourth. This says a negative out front means take negative 1 times 2 to the fourth, which is 2 times 2 times 2 times 2. 2 times 2 times 2 times 2 is 16. So this is negative 1 times 16, or negative 16. This says, oh, that's in parentheses. So I take negative 2 times negative 2 times negative 2 times negative 2. Well, negative 2 times negative 2 is a positive 4. Negative 2 times negative 2 over here is a positive 4. So this equals 16. They're not the same. This one's going to be negative 16. This one's going to be 16. Because this says the parentheses is part of the 2 and multiply it by itself 4 times. This is saying take the negative of 2 to the fourth. 2 to the fourth is 16. I'll take the negative of that. Our lesson points that out right down here. The negative is inside the parentheses. So that's a nice little reminder. If you need more examples of the order operation, I'm going to spend a lot of time. This should be a review from a couple of years ago. But if you need more examples, please go through these. See if you can simplify that. See if your answer matches what they get. All right. If you have more than one set of parentheses, work from the inside out. That's a good thing because there's a bracket and then a parentheses. And so you got 10 minus 12 in parentheses. And then you have divided by 2 outside the parentheses, but inside the bracket. So the first thing you would do was simplify the 10 minus 12 to the negative 2. And then it's still inside the bracket divided by 2. So then you simplify that next to just a negative 1. Then you can continue on. So good stuff here. Click on these links anytime you see that to see what other information it has. And it's worth reviewing. I'm not going to review every little thing because you've got this lesson and we got to get through 2 lessons today. So I won't do everything, but we're going to hit the highlights to make sure everyone understands. Okay, let's look at solving one-step equations. One step. That means all you have to do is one thing and you're done. Like x plus 4 equals -7. Wait a minute. Let me make sure I'm sharing this properly. Because if I don't share it right, you won't hear the sound. If there's sound. I don't know if there's sound in here. We're going to see if there's sound in here. All right. Now you should hear sound if they give us sound. I don't know. Not all of them have sound.
In this equation, 4 is being added to x. So to solve for x, you must subtract 4 from both sides.
They're building their big old Megalopolis.
So x equals -11. There we go. And then it covers up our answer right there. I love it. Now if we go. Yeah, -11. One step. All you have to do is just get the x by itself, right? Gives another example, x minus 5 equals 3. So 5 is being subtracted from x. So all we have to do is add 5 to both sides. So this will just be x because that 5 will go away. And 3 plus 5 is 8. So this is a 12-second video. It'll show you that.
Here, 5 is subtracted from x. To solve for x, add 5 to both sides of the equation.
X equals 8. Perfect. So here's some others that are one step. Like here's x divided by 8. Let's see if I make that bigger. There we go.
Here, x is being divided by 8. To find the value of x, simply multiply both sides of the equation by 8.
X equals 16. So basically you're doing the opposite of whatever. If x is being divided by 8, you multiply by 8. If x is being multiplied by 4, you divide by 4. Square root. Oh, this is a good one. So if we have the square root of x, the opposite of the square root is squaring. All right. So let's look at that.
This equation shows the square root of a variable. To eliminate the radical sign, you must square both sides.
X equals 100. And just the opposite here. You take the square root of both sides, the square root of 9. I mean, square root of 81. Let's see if it gives us, technically there's 2 answers.
In this
there.
equation, the variable x is being squared. To eliminate this exponent, take the square root of both sides of the equation. Don't forget that the square root of any value will have 2 solutions.
That's right. Positive 9 and negative 9 are both solutions because negative 9 times negative 9 is also 81. So one-step equations are very simple. We're not going to spend much time on that. 2-step equations, a little bit more, but still you've done a lot of this in Algebra 1, Algebra 2, even geometry. You did some of this. Let's look at this video real quick, just as a refresher. 34-second video. Again, let's just review.
3x plus 9 equals 30. To isolate the variable and solve this equation, start by subtracting 9 from both sides of the equal sign. Simplify. 3 is multiplied by x. In order to undo this operation, divide both sides of the equation by 3. 21 divided by 3 is 7. Therefore, the solution to the equation is x equals 7.
All right, so you have all these videos in the lesson, so you can go back and review any of these, and they'll step through it like we just watched and show you how to do that. And here's more examples of 2-step equations if you need more examples. Like this one is 2 times x plus 4 minus 16 equals 10. And it will step you through every step to solve that to where you get x equals 9. And you have, so don't be afraid to go through all these examples if you need the refresher. If you've got this upside down and backwards, like, man, Mr. Brock, I can solve that while I'm asleep. Then maybe you don't need to look at all the examples. It has all this extra examples for you based on how much you need to be refreshed. Like I said, this is Algebra 1 stuff, and you may have it really good. It's like I can solve that, no problem. Let's look at this one that has an x on both sides. Let's see which example we want to do. Let's do this one. It's really complicated with x on both sides. Let's look at this. Like I said, you have all these that you can go back and review anytime you want to. Well, this one apparently has no sound. So it says distribute 5 because it's outside the parentheses. So we have to take 5 times x, which is 5x. And then we have to take 5 times 2 because that's the other one that's inside the parentheses. So 5 times 2 is also added to the 5 times x. Then it equals, now we have a negative 2 outside the parentheses. So we have to multiply that by both items that are inside the parentheses. Negative 2 times 3x. And we also have to take the negative 2 times the negative 1. Or, as they do, minus negative 2 times positive 1. Either way. And then you still have the 3x on the end that we've done nothing with. So now let's simplify what we have. We have the 5 times x plus 5 times 2, negative 2 times 3x minus negative 2 times 1 plus 3x. So if we simplify those, 5x is just 5x. 5 times 2 is 10. That's negative 6x. And this is minus a negative 2. All right, minus negative 2. And then we still have the 3x on the end. So they've solved that down at the bottom. So what can we combine? They took the minus negative 2, and that's the same thing as the positive 2. And then these are both x terms. So we can put those together. Negative 6x plus 3x. So you have negative 6 and positive 3 is a negative 3x. And we haven't done anything with the rest of it yet. So now we want to get the x by itself. So there's a negative 3x over here. Let's add it to both sides. It goes away over here because negative 3 plus positive 3 is 0. Over here, now we have 8x plus 10 equals, we still have the 2. We need to get rid of the 10 because it doesn't have an x. So we subtract both sides. So now we still have 8x equals 2 minus 10 is negative 8. We have 8 times x, so we need to divide it by 8 to get x by itself. We're still trying to eliminate everything except for the x. So if we divide both sides by 8, 8 divided by 8 is 1, so we just have 1x. And negative 8 divided by 8 is negative 1. So that is the solution. X equals negative 1. And again, you have these. You can go back. You can go back and look at this one. This one's simpler. But all of that is there at your disposal. Let's look at page 5. All right, here's some sample for us to try. We've got, this is order of operations. 10 over 2 plus 3. So if we want to click on that one, what do we do first? Well, this has parentheses. So we have to simplify what's inside the parentheses first. 10 divided by 2. Well, that's 5. 10 divided by 2 is 5. So we got 5 plus 3. So 5 plus 3 is 8. So if we click on that and then click on the 8, they disappear because we got it right. Okay, this looks a little more complicated. We have an exponent. We have addition. We have multiplication. And we have subtraction. No parentheses. So we can skip that. Exponents. Well, the first thing we do would be 4 squared. Remember, when we square something, we multiply it by itself. So that's 4 times 4. So this is 16. So we have 16 plus 7 times 2 minus 3. 16 plus times minus. So we need to multiply. That's next in the order of operations. 7 times 2. That's 14. So now we have 16 plus 14 minus 3. So now we just go left to right. 16 plus 14 is 30. 30 minus 3, oh, it must be 27. So let's click on that and click on the 27. There's 2 left. This one's got division, because when you have a fraction like that, that's 9 divided by everything that's on the bottom. But we also have an exponent that's being squared, but we also have parentheses. So parentheses is always first. Negative 2 minus 1. Negative 2 minus 1. So it's getting more negative. So that's negative 3 negative 3 squared. So that's negative 3 times negative 3, because exponent would be next. So that's 9. 9 divided by 9. So now we know the answer to that one. See, if we click the wrong one, it just says that's wrong. It won't disappear. But since we know 9 divided by 9 is 1, this must equal 5 by process of elimination. It's the only choice we have left. And you can restart it and try it again if you got confused the first time. All right, let's see what we have here. Let's solve this one together. We'll get our paper back up, but let me write the problem down first.
These are, it's a practice grade, but these are questions that will be on your
6x minus 10 equals
So when I
x.
send this back to
Okay.
you, it's like,
Let me switch over to that.
okay, do I need to go over that again?
6x minus 10 equals x. So to solve this, we're trying to get all the x's on one side and get it by itself. We have x's on two sides. Well, since this one's bigger, I'm going to move this one over there. You can do it either way, but I like to do the bigger one just to keep it positive. So we can subtract x.
Yeah, that's the amount of land and that's.
That means this is 6x minus just 1x. So we have 5x. We still have the minus 10. And what x minus x over here is just 0. We have nothing left on the other side. But we only want x's on this side of the equal sign. This does not have an x. So let's add 10. So we have 5x equals 10. X a little darker there. 5 times x. So we need to divide that by 5. So 5 divided by 5 is 1. So we have 1x equals 10 divided by 5 is 2. There's our answer. Now I was talking about how you can go either direction up here. I want to show you what it looked like if we went the other way, because we can still do that just as easily. But I just like to work with the positive number. So if we started with 6x minus 10 equals x, and you're like, I've already got x on by itself over here, so let me just move the 6 that direction, because you can do it either way. So I would need to subtract 6x over here on both sides. 6x minus 6x, that went away, so all that's left is negative 10. X minus 6x. Well, now it's a negative x, right? 1 minus 6. I have negative 5x. So now I need to divide by negative 5. Well, negative 10 divided by negative 5, that's a negative divided by a negative, so that's positive. Negative 5 divided by negative 5 is 1. We still get the same answer. Actually, one less step if you don't mind working with the negative. But either way, you should get x equals 2. So you can go either way. You just put all the x's on the left side or put all the x's on the right side. Whichever you want to do, it will not make a difference if you do it correctly to get the answer. You should get the same answer either way. But I just wanted to work with the positive x's, not have to deal with the negative x's. So 6x minus 10, our answer is 2. Submit. Awesome job. And then it walks through these steps. It did the same thing I did. It subtracted the x, made 5x on this side, 10 on the other side. Down here, you can't really see it too well, but there's some buttons. Let's click that button, and there's another problem. Oh, see, now it popped up. There's 5 problems here, hidden down here in the menu. So let's work another one. Just for more practice, because that's what these are for. These are the practice problems that tell you if you're right or not. So this is a great time to get your pencil out with your notes. There you go. Great time to get some paper out and work through this. So I'm going to go ahead and move it this way this time. Minus 2x. So this is x minus 2x. So I got negative x plus 3. That went away. Negative 5. I need to get rid of the 3 because I just want x's on this side. Oh, not equals. Negative x equals negative 5 plus negative 3. Negative 8. divide by -1. X equals 8. If negative x equals -8, then x equals 8. So if we go back to Buzz and I tell it, hey, I've worked this on my paper and here's the answer I came up with, it'll tell me if I'm right or not. So let me emphasize that. Every lesson, just about, not, yeah, but this Algebra 3, we run some. There are lots of practice problems built into Buzz. So you can go there on these pages towards the end of the lesson and work these practice problems. Work them on paper and then check to see if you're correct. If you can do all of these wonderfully, you can do the assignment and not have to worry. You can take the test and not have to worry. If you just skip these, go, oh, yeah, okay. And then you get to the test and it's like, oh, wait a minute. What was the next step? I don't remember. That's what the practice problem is for. So you don't have to go to the test and go, right? And then if you do all of these, look, you've got built-in notes. So when you take that test, you can say, oh, what do I do? Oh, wait, I got notes. Oh, that's what the next step. Okay, yep, I worked a problem that was almost exactly the same right here. I'm going to go through my notes. Use your notes. You can use them on tests. You can use them on assignments. You can use them on quizzes. Whole class. Use it on the semester final. Use your notes. So, all right. So that is, like I say, there's 3 pages. 3 different sets of problems. And they have other, once you work it, there's other 4 or 5 problems in these little sets. The last page always tells you to read the lesson, make sure you can develop responses to the questions they had on page 1, which tells you again what the questions were on page 1. And then make sure you do the assignment. This is an auto-graded assignment, which means it's all multiple choice. So after we've done this, algebra review, algebra 1 review, this has a different little icon. This means this is an assignment. Revisiting functions lesson, revisiting functions assignment. So let's look at the first assignment that just went with what we reviewed. I got a 0 on it right now. Solve -5x equals 15. So I'm going to get that on paper. I'm going to work through it all. And I'm going to say, okay, there's my answer. Solve x divided by 4 equals 8. So I'm going to put that on paper and I'll select my answer. And then I'm going to say 2x minus 9 equals 15. Work it all on paper, select an answer. See what we got. We got 9 problems. All right. So work through your 9 problems. Do them on paper. This one asks you who made the mistake and what they do wrong. Because they were both had the same problem, Susie and Amelia. I'm rooting for Susie. That's my wife's name, but I don't know if she did it right or not. I haven't reviewed it. But you can tell the order of operations they did. Trying to solve these equations has an x on both sides. Exact same equation, but they came up with 2 different answers. This person says it's -1/2. Susie said it's -5/2, which is -2.5. 2.5. So this one's a half, -2.5. One of them is wrong. So either Amelia made a mistake, and at what step did she make a mistake, or Susie made a mistake, but was it when she subtracted 2 or when she subtracted 2x? Because one of those was wrong. But anyway, 7 problems. When you get done, go down and make sure you submit it. Submit your answers. I've only done the first 3. I'm not going to submit mine. I'm just going to save and exit, but it'll save it for you. All right, so that's the first assignment. Let's look at our second lesson because we're doing the first 2 lessons this week. Revisiting functions. We're going to talk a lot about functions, so we need to know what a function is. In his play Romeo and Juliet, Shakespeare wrote, "A rose by any other name would smell just as sweet." Well, in fact, roses do have another name. Scientifically, roses in general are referred to Rosacea, Rosadea, Rosa. That's the technical biological name of what that plant is. Even you have different names. You got a full name. You may have a nickname your friends call you by. You may have a different nickname that your mother calls you. All kinds of names. And many of the equations you've been working for years also have another name, but they're just as sweet. I love it. All right. So we're going to learn what's the different methods to identify a function, what processes are needed to solve functions and their inverses, and how's the composition of functions related to the order of operations. So let's look at this lesson. Equations versus functions. There's a difference. The mathematical term function applies to some equations, but not all equations are functions. All functions are equations, but not all equations are functions. Just like all plants are roses, but not all, roses are all plants, but not all plants are roses. So here are some equations you may have seen. X squared plus y squared equals 1. If you graph that, that's a circle. That's the equation of a circle. X plus 7 equals 20, equals 10. That's a line. It'll make a line. It'll make a horizontal line. If you graph that, a vertical line, up and down line. Y equals 2x plus 3. That'll make a diagonal line on your page. And then y equals x squared minus 7x plus 6. That'll make a parabola. So those are 4 different equations you function. But let's take a look at more in depth. Anytime you see this color, click on it, see what's underneath it. So in order for an equation to be a function, now we're getting down to definition, there must be only one y value for each x value. Okay. Out of the 4 examples above, 2 of these are functions, 2 of them are not. This y equals 2x plus 3 is a function, because if we make a table and we put in values of x and calculate what the y is, look, -2 only has one y value, and it's -1. -1 only has one y value, and it's 1. 0 only has one y value, it's 3. When x is 2, it's only got one y value, it's 7. So every x only has one y. So this is a function. So we can close that one. Let's look at the parabola, x squared minus 7x plus 6. There must be one y value for each x value. So let's look. If we put -2 in the equation for x and calculate it, it'll calculate to 24. Only one y. That's the only y that'll be. If we put -1 into the equation and calculate it, there's only one answer. It comes up with 14 as a y. If we put in 2, it'll calculate to -4 as the y. Again, only one y for every x we're calculating. Shay, you can follow along on Buzz, or you can just follow along on the screen. That's totally whichever way you want to do that. But I'm just reviewing what the lesson shows. And if you want to go into more detail in the lesson later, you can always go back and look at any examples that I skipped. But so basically, we'll go through this as a class and look at it. And then you have access to it, so you can go back and take longer to go through a problem, or look at other problems that I may not have looked at, just other examples. So however you feel comfortable with that. Good question. Okay, let's look at the next one. X squared plus y squared equals 1. If we put -1 into the equation, we end up with 0. Okay, that just has one y. If we put a half squared plus y squared equals 1, and we solve all that for y, we get 2 answers. It could be square root of 3 over 2 or negative square root of 3 over 2. There's 2 different y's for the same x value at 1/2. And at 0, if we put 0 in, it could be 1 or it could be -1 for the y. There's 2 different answers. So this is not a function because there's more than one y value assigned to the same x value. And we only have to find that once. Once you see that one time, it's not a function. Even though some of them only have one y, you only have to have one time that it doesn't, and it's not a function. X plus 7 equals 10. It's an up and down line. Like I was saying, a vertical line at x equals 3. So what y's does it have? It has 0, 1, 2, 3, 4, 5, -1/2, -1/3, -1. There's a whole bunch of y's. Every single y is included in that line. So it is not a function. So functions are great for graphing on the coordinate plane because they have one variable for the input, the domain x, and another variable for the output, the range y. Equations that have multiple variables can be complicated to graph because there's so many inputs that affect the output. So If you want to chart the growth of kudzu vines in Florida or Georgia or South Carolina, there's a bunch of kudzu down there. Kudzu is interesting. They imported it. It was not natural to North America, but it grows very fast. So they said, well, we have all this area where there's lots of erosion that all of our soil is washing away. So if we plant some kudzu, it'll fix it. The problem is kudzu can grow 12 inches a day. So now the kudzu's out of control. They brought it over after World War II, and now kudzu, they can't stop it. It grows so fast, they can't cut it down fast enough. So it's absolutely crazy. So to chart the growth of kudzu, there's multiple inputs like the temperature and access to water that could affect the growth. In science, the X and Y variables referred to as independent and dependent. So, all right, to help us understand functions, we're going to match the movies below with the release years. Does anyone know what year Twilight was released? Or Madagascar? Or Dead Man's Chest, The Pirates of the Caribbean? Or The Dark Knight or Enchanted? They were all around 2005 to 2008 when y'all were just babies or not even born yet. Let's see. Let's see. Twilight. Let's go 2008. Oh, that's not right. Oh, it is 2008. I just had to click on the other 2008. So Twilight was 2008. I don't want to guess what else might have been 2008. There's another 2008 here. Let's see if it was The Dark Knight. Oh, it was. It was. So now we're going to match these. One of these was 2005, one of these 2006, one of these 2007. Madagascar. I'm going to say it's the oldest one. Oh, I'm doing good. I'm doing good. I must watch too many movies. Enchanted. I'm feeling 7. Oh, there it is. So if I hit the restart button. Now notice, this is a function because each movie is only released in 1 year. They don't release, hey, we got this new movie called Madagascar. Let's release it in 2006 and then release it again in 2007. No, it's only released once and then it's out there. Then people can go watch the movie or they can go buy the movie. It's been released one time. But notice we've got 2 2008s. 2 movies were released in the same year. Well, that's okay because if this is our X, it's only released in 1 year. Now, if we reversed it and we said, okay, let's look at years and movies released, that's not a function because each year there's more than one movie released. It only works when movie is the X and the year is the Y. So you got to do it in the right order for it to be a function. So notice that each movie, the domain, matches only 1 year, the range. So if the value in the domain goes to more than one value, then it's just a relation, but not a function. It's a relation. All right, page 3. The vertical line test. So maybe you don't want to make a table, right? Because we made a table on page 1 and look to see if there's more than one Y for each X. You can also just graph it. Let's take this second math. See, there's where we can substitute the values in. But if we graph it, notice this graph. It's a diagonal points. If we connect all those, it's just going to be a line, right? A diagonal line. And if we want to check, if we do a straight up and down line, they did it in red, does it touch that graph more than once? Which would mean there's 2 different Y values. No matter where we move it along there, it only touches that line once. The red line only touches the blue line once. So this is a function. That is a function. Let's see. Let's look at more examples. Vertical line test. Is this a function? If we do an up and down line, is there any place that it will touch this graph more than once? No, it doesn't look like it. Let me check that. So if I have this right here, I have, and I'm checking an up and down line. Let's see. I'm just going to put my pencil on. Nope, only touches the graph one place anywhere I go. So this is a function. That's a function. So I'm going to say function. Submit. Yes, it is the function. Let's look at another one. Next. Vertical line test. All right, let me draw another one. All right, so I've got this one now. If I do my vertical line test, I should find what I did in my ruler. Here's a ruler. Oh, I caught my headphones in the drawer. Okay. Oh, look, when I check it with my vertical line, it touches the Y up here and touches the Y again down there. There's two Y's. There's lots of places there's two Y's when I do the vertical line test. This is not a function. Not a function because it touches it more than once. Non-function. Submit. Correct. How about this one? Vertical line test. If we do a straight up and down line, yeah, it looks like that's only going to touch it one time. So that must be a function. Submit. How about the next one? Now look, this is a absolute value graph. Up and down, we're going to touch it twice. If the up and down line's at -2, we're going to touch it at 2 and down here at -2. Not a function. Circle? Oh, there's lots of places where we touch it twice. Not a function. How about this one? Oh, it looks a little different, but will it touch it more than once? Doesn't look like it. Should be a function. So if you're confused about that, you can restart. You can go through this on your own and see if you understand it. It just helps to know, do I understand? Determine which graph is a function and not by performing the vertical line test. All right. Function notation. Let's talk about that as well. Function notation. So we said that like this is a function. Oh, this is my pencil. I need to move that because it's the one that's dying. Y equals 2x minus 3. This is a function. It makes a graph that just goes like this. All right. Vertical line test, it's only going to touch it one time anywhere along there. Function. Yes. But we can use function notation. Let's write that. Function notation. Again, this shouldn't be the first time you've seen this, but instead of y, we can say function x equals 2x minus 3. These are exactly the same. These are the same function. Same. We can either write it as a y equals or write it in function notation. So that's important to recognize because anytime we see this, this really means it's a y. Y equals whatever when we calculate that, when we put an x in for that value. All right, so that's what this is saying. Could be written in function notation. F of x equal, they use 2x plus 3. I use minus. And that's how you read that, f of x. It replaces the y variable. So if you want to find like what does the y equal when x equals -6, we take -6 and substitute it into the equation for the x. 2 times -6 plus 3 is -12. Plus 3 is -9. So that means when you graph it, the point -6, -9 will be one of the points on the graph of that equation. All right. And here's more examples on function notation and the domain and range. Like find the function when the value of x is 4, f of 4. That just means take all the x's and replace them with 4s, as they did right there. So f of 4, which means when x equals 4, this equation will equal -6. Because that's when you do the math, that's what that equals if we take out the x and put in a 4. So f of 4 equals -6. We'll be reviewing that more throughout the year. Let's look at page 4. Inverses. An inverted roller coaster is a ride where the cars are underneath the track as they travel along. There they are doing a loop upside down, but they're on top because they're inverted. An inverted airplane is one that's flying upside down with the tail pointing downwards. Inverting the colors on a photograph turns black colors to white, white colors to black, and it looks pretty funny. So inversion is the process of reversing the order or position of something. It's like if we want to find the inverse of a number, that means what number is the opposite that would cancel it and make it 0. So the inverse of 7 is -7. 7, -7. Or if we want to cancel it a different way, we could say the reciprocal of 7 is 1/7, because when you multiply those, they just equals 1. So there's different ways, depending on what we want to do. Do we want to cancel the 7, or do we want to find its reciprocal? So let's look at finding the inverse of a function. So I'm going to walk through this function on paper to show you. They have a video of it, but I'm going to do it. I'm going to do it on paper, put it in our notes. And you can watch the video, but it should do the exact same thing. So here's the steps to find the inverse of an equation.
I'll pop right over to yours as soon as I get done going here.
And we'll graph this when we're done too. So to find the inverse, find inverse. First, change out of function notation, change to y equals. So y equals 3x minus 5. See, we had it in function notation. Now we've got it in y equals notation. Swap x and y. So we'll take the x and y and trade places. So now it's x equals 3y minus 5. And then we'll solve for y. So we need to get y by itself because we're solving it for y. So add 5. X plus 5 equals 3y. Divide by 3. So y equals x plus 5 divided by 3. We can't simplify that without knowing what x equals. I mean, we could also write it x over 3 plus 5/3. That's the same thing. These are equal to each other. So we generally leave it like this. So this is the inverse of this. And we can tell something when we graph that. Because when we graph it, it will reflect, it'll be like a mirror over y equals x. So let me show you that. Instead of just telling you, I'm going to show you because it's not fair to just tell you. Desmos calculator, graphing calculator. Desmos. We can use Desmos to graph a lot in here. So the original equation we said was y equals 3x minus 5. So there's the graph of y equals 3x minus 5. And I said it would be a reflection over the line y equals x. So there's that line. So if its inverse is going to reflect over that, we should see it just like a mirror going the other way. And we said the inverse was y equals x plus 5 divided by 3. Oh, look at that. It's a perfect mirror over the blue line. The green line is exactly the same distance away as the red line is everywhere. And it crosses in the same point.
Mary, does that answer that question?
Yeah, we can see it's just a mirror. It's just a mirror reflection of that y equals x line.
Okay.
Same distance away. So that is the inverse.
How can I help you?
And this will take you through that as well. So you can watch that. It's 1 minute and 7 seconds. Oh, and they graphed it right there to show you the inverse graph, just like we did.
Did you download the file? Okay.
So that means if it has the point 0, -5, the inverse will swap places, -5, 0. 2, 1, 1, 2, inverse. All right, here is the steps to find the inverse of f of x equals x squared. First, we change it to y equals. Then we swap the x and the y. See, now it's x equals y squared. Solve for y. If we want y by itself, we got to take the square root of both sides. So y equals the square root of x plus or minus. And then we can say function notation again, f of -1 x, it means the inverse function. And then if you graph it, notice it's no longer a function. It originally was a function, x squared was a function, but plus or minus the square root of x is not a function. Does not pass the vertical line test. Here's another example. You can go through, replace y. So I won't go through all the examples, but they are there for you if you're still confused on the steps to find the inverse. Here they are. If you want to write those in your notes, here are the steps. It has that in our lesson as well. Those are the steps to find the inverse. Change it to y equals, swap the x and y, solve for y. To find the inverse. There's the steps you need. All right, for anyone writing that down, it's there. It's also in the lesson there. So let's look at page 5. Composition of functions. That's the only other thing we haven't done. And we'll look at those. I say it gives several examples, but I'll do some examples on paper. And that's the lesson summary, so that's the end of it. The lesson summary is a great place to, if you want to keep a notebook with your notes and have a printer, this will summarize everything we just talked about. Operations on functions, inverses of functions. There's steps right there to do that, including writing it with function notation. They switch it back at the end, f of -1. Composition of functions, which we're about to talk about right now. It's all right there on the summary. But let's just do some functions ourselves and do composition of functions. So don't need that anymore. Composition of functions. So let's say we have two functions, right? One function is f of x, and it equals 2x. Very simple function. Then we have another function. We're going to call this one g of x. So it has a different name, so we can tell them apart. So if I talk about g of x, you'll know what I'm talking about, and you won't be confusing with f of x. And this is going to be x minus 3. So we have two functions. One is 2x, one is x minus 3. With composition of functions, it works like this. We might say f of g of x. You're like, what? Because remember, what's in parentheses is the x, which is saying if we did f of 3, all that tells me to do is to go in wherever there's an x and substitute a 3. So that would be 2 times 3 or 6, all right? Just barely have room to write that 6 over there. So f of 3 would be 6 because I'm just taking out the x and I'm putting in a 3 because I took out the x here and put in a 3. So what does this mean? That means instead of x, take out the x and put g of x in for that. That's all it's saying. So that means, okay, so it's 2 to, instead of x, it's going to be x minus 3. See what I did there? I took g of x, which is x minus 3, and I substituted it in for the x.
So here's an example.
That's all that means. And then I have to simplify it. So f of g of x
You can point at the source of the pollution. Like, oh look, there it is.
equals distribute 2x minus 6. That's what f of g of x equals.
Straight into the ocean. I can point at that. I know
I just took out the x and substituted what was in the parentheses for x, which was g of x. Now,
we have smog and
does that mean this is also going to be 2x minus 6?
like it could be from Walmart. It could be from
See, now I went the other way.
it could be from
I'm taking, well, let me do it in a different color highlighter here. I took out the x and I put in f of x. I'm going the other direction this time. So that equals x. Well, I don't want x. I want f of x. 2x minus 3. Because that's what x was. X was there. But I substituted f of x, which is 2x. So f of g of x equals 2x minus 6. G of f of x equals 2x minus 3. They're not the same. They can be the same, but a lot of times they're not. So that's what I mean by composition of functions. And it can be more complicated. Let's say that f of x equals x squared minus 1, and g of x equals 2x. Yeah, let's make it something else. We had f equals 2x last time. Oh, that's a terrible eraser. Don't use that. Yeah, I got to get rid of that eraser. That's terrible. Let's say it equals 4x. Just have something different. So if we want to calculate f of g of x, this time, still we're going to take the x and substitute with 4x instead. And the 4x is squared because it's x squared. The 4x is squared because I just took out the x and I put in 4x. So now I got to simplify this. F of g of x equals 4x squared. That's 4x times 4x. When I square something, I just multiply it by itself. So that's 16x squared. So this equals 16x squared minus 1. That's it. If I went the other way, g of f of x equals 4 times x. Well, in this case, x squared minus 1 would be what the x is because I'm substituting all of this equation. So it equals 4x squared minus 4. Very different than the original. All right, let's do one other example. What if I said, I'm going to use these same ones. I'm not changing my equations. F of g of 3. Oh my goodness, Mr. Brock. Now you're totally confused me. One thing at a time. One thing at a time. First of all, we know that we're using the f function. The f function. Instead of x, we're going to use g of 3. Well, what is g of 3? What am I putting in there? Well, g of 3 means instead of x, I'm substituting 3. So g of 3 means 4 times 3, not 4 times x, because I'm substituting out the x, which that's just 12. So that means this is f of 12, because that's what g of 3 equals. G of 3 equals 4 times 3, because it's 4x. So f of 12 means I substitute 12 in. 12 squared minus 1, which equals 144 minus 1, 143. So f of g of 3 equals 143. Composition of functions, taking one function and putting it inside of another function. That's what it means to compose functions, a composition of functions. And they have many, many examples on this page. Starting at the top, it starts with a word problem. It comes up with two functions, x plus 1500 and 3x. And then it does g of f of x, where it takes the x plus 1500 and substitute it in for x. So it gets 3 times x plus 1500 and simplifies it to 3x plus 4500. Or it does it the other direction right here, f of g of x, where it substitutes 3x in for the x, and it's 3x plus 1500. Then you could, g of f of x, this is another way to write that, g of f of x. They use a little circle instead of doing it like this. This is the same thing. I guess I should show that in our notes. F of g of x is the same as f circle g of x. Those mean the same thing. It's just two different ways of writing the exact same thing. Same. F of g of x or f of g of x. So don't let that confuse you if you see it written the other way. It's the same thing. So they talk about that here. G of f of x, f of g of x. Here's another example using 7x and 3x plus 10. Define f of g of x or g of f of x. Let's see, here's that 10x minus 3 and x plus 6. Find g of f of negative 1. So the first thing you do is substitute negative 1 into the f equation. All right. Substitute negative 1 into the f equation. You get negative 13, and then you substitute negative 13 into the g. And they show you a second method to do that, where you could combine the equations first and then just solve it for the negative 1. Another example, verifying the inverses. If you want to verify them, you substitute them together and solve it if they're inverses. If they're inverses. Now we talk about inverses and how inverses graph to do this. So let's verify that those are inverses algebraically. That's a good exercise right there. So we did f of x. What were the two that we did as an inverse? Let me write it in here. 3x minus 5. And our inverse, I guess I'll write it in. I got to stop using that eraser. I do not like that eraser. Inverse equation would be f of negative 1 of x equals the x plus 5 divided by 3. So if we want to find out if these are inverses without graphing, we just substitute one into the other. We do f of f inverse of x. So that means we take 3 instead of x, let's substitute this in, x plus 5 divided by 3 minus 5. So I substituted that one in for x over here. Now to simplify it, I've got 3 times x plus 5 divided by 3. Those 3's are going to cancel each other out then. If I multiply by 3 and divide by 3, I end up with just x plus 5 minus 5. Oh. Plus 5 minus 5 cancels out. If these are inverses, that's what it will simplify to, x. Both directions. If I take f inverse of f of x, I'll have x plus 5, but x is, instead of x, is going to be 3x minus 5 plus 5 divided by 3. See what I did? I just took the x right here and I substituted 3x minus 5 in for it right there. So it's x plus 5, or 3x minus 5 plus 5 divided by 3. So if we take 3x minus 5, that's as simple as it gets. So take minus 5 plus 5, those will cancel each other out. So this equals 3x divided by 3. 3 divided by 3. That's how you verify if two functions are inverses of each other. And we'll work more with that at some point, I'm sure, too. But you verify it by substituting it in. And the only way to get good at that is to practice it, quite honestly. And here's one that you can try on your own. Verify that f of x equals x minus 2 over 6 is the inverse of this g of x, 6x plus 2. Substitute this in for x in that one and simplify it. Substitute this in for x in that one and simplify it. And if it equals x, when you simplify it, those are inverses. And it shows you how. If you get lost, try it on paper, and then it has all the answers right there on how to do it. And there's the lesson summary, which summarizes everything that you can use in your notes. And yes, they do have some practice problems on page 6, as usual. So if this is the equation, what is f of 0? What is f of negative 3? What is f of 4? So you take this and drag it to the correct answer, right? So f of 0, if I drag this there, that's the correct answer. So that's and then there's another set of problems over here. You try to find the inverse. Here's the equation, find the inverse. And then you can check to see, did I get it right? And then there's another problem. Find the inverse of this one. Did I get it right? Did I get it right? Then it says, make sure you read the lesson and do the assignment. So let's look at the second assignment real quick. Revisiting functions here. All right, you have 3 attempts. Let's see, multiple choice. 1, 2, 3, 4, 5, 6. You have 10 multiple choice questions. They're all multiple choice. Some of them want you to find f of negative 1. If you substitute negative 1 for x, what's it equal? Well, that's pretty tough, Danielle. That's bad. F of negative 1 for this equation. What is the inverse of this equation? What is the inverse of this equation? What is f of g of 2? F of g of negative 1 using these two equations. Just what's f of g of x? If you just take g of x and substitute it in there and simplify it, which one of these does it equal? So 10 problems. If you have trouble with them, email me. We can get together. We can help. Again, remember, I am not here on Wednesday because I have an appointment in Little Rock, so I'm not here on Wednesday. So you will have a Google Classroom assignment for attendance. So I didn't want you to forget that. Make sure you go do that attendance assignment. Like I say, it won't take 2 minutes. It's just a real quick little questionnaire just to show that you came to class. So, all right, guys. That's your assignments for the week. Next week is Labor Day. No school on Monday. So next week we'll only meet on Wednesday, and Friday be an A day. That will be non-synchronous, asynchronous, unless your grade's below 70%. So you get 3 attempts on these this week. If you have trouble with it, if you still struggling at the first 2, get with me before you take that 3rd attempt. But all right, guys, have a great week. I'm gonna let you go. Took longer than I like to, but that was it. We'll see ya.